Let's begin recording on this wonderful Friday afternoon. So today's lesson is actually very important. We're going to be talking about the standard library today and iterators. And these concepts are really fundamental, really important in C++. When you know the standard library, you know what's been done before, and you don't have to waste your time repeating work that's already been done. Like a lot of computer science professors teach students like write a sort algorithm. And that's probably good practice. Like you should probably have written a sort algorithm at least, a few times in your life, right? But in practice, no, you should unless there's some weird specific thing you need, you should not be writing sort algorithms. Instead, let me show you here. Let's make a vector of integers named vec that is equal to 30, 10, 50, 40, 20. There is a function called sort, and you sort it from the beginning to the end, and then you can print out, make a print function, why not? Void print. I'm going to show you something cool here, promise. It doesn't have to be a vector actually, but for every element in the vector, we will see out that element, and this print function will work with basically any of the standard data structures that we're going to work with in this class. So if we had a list, well, we don't have it included, but yeah, so what this code's going to do, it's going to create a vector whose values are 30, 10, 50, 40, 20. We call sort on it, one line of code, they're all sorted, we then print it out, okay? So let's go on and print. So if we run it, we then get 10, 20, 30, 40, 50. So sort takes something called a range, and this is our learning point. Number one for the day is the concept of a range. So this is not the range from algebra, which is there's the domain, the range, or whatever, nothing to do with that. Instead, a range is a pair of iterators or pointers. Okay? And you'll actually hear me use the term iterator and pointer interchangeably, which is incorrect. But I do it deliberately because conceptually, they're the same thing. An iterator is actually a class that pretends to be a pointer. So, for example, if you wanted to make an iterator, you could do this. Auto bob is equal to vec.begin. And we could say bob points to the first element of vec. And so if I wanted to see out the first element in vec, if I have a pointer to the first element in the vector, how do I see it out? What is the syntax for dereferencing a pointer? Anyone remember? It's not a pointer, but it acts like one. That's why I almost deliberately make a incorrect statement, because they're really deliberately interchangeable. Star Bob, that's right. Just like that. Now if we do that, you'll see that it prints out 30. All right, let's make it a little bit more complicated. Bob now points to the end of the vector. If I see out Bob now, what value is it going to print? Anyone want to take a guess? Where does the end pointer point to? The usual range is vec.begin to vec.end. 20, 20, and 0. 0, 20, 0, 0 it is. Now the reason for that is because there's actually a secret last element in the vector. That's actually what end is pointing at. End, and this is something that everybody gets wrong. Vec.end points to the element after 20. Okay? Does not point to 20, it points to the element after 20. like here. Like literally where that comment is. Like where that comment is where end is pointing at. It's pointing to one past the end. And the reason for that is because a range is a half-open pattern. So it's like this, right? When you say like 0 to x, like that. Right, like when you do for loops, you know, like you do a for loop like for int I equals 0, I is less than but not including x, I plus plus, right? It does not include the last element. So anytime you have a range starts at the first pointer and ends one before the second pointer. It's like a less than symbol. It goes up to but not including end. And so when you say sort from the beginning to the end, it sorts everything. It does not sort that last element. Anytime you take a range, it's a half-open pattern. Starting at the beginning, going up to but not including the end. Okay? So it's the same pattern we do with a for loop as a regular for loop, right? Okay. So how could I print the last element in Bob? Well, I could say vector.end -1. That works. That will point at the person one prior to the end. So anyone want to guess what? Oh, that's a little bit too easy. Let's do -2. What is this going to print now? So if the end is pointing here, and we move backwards 2, what value is this going to print to the screen? Indeed. 40. Okay. Likewise, we could say vector.begin +2. Which number is this going to print out? 2 to the right of the beginning. And that's something about iterators. Every iterator has a ++ operator defined on it, so it can move 1 to the right. And some of them have the ability to move like 2 to the right or move backwards and things like that. So 50, 40. So if Bob is pointing at this guy, if vector.begin, I should say, sorry, is pointing at 30, then if we move 2 to the right, it's going to be pointing at 50. Okay. Got 50 there. Okay. And so if you want to sort part of the array, for example, if we wanted to sort like the second half of the array, we can start at vector.begin +2 and go to vector.end. So the first element of the range is 50. So we've got a pair of pointers now. Iterators, like I said, they're essentially the same thing. With a pair of pointers. Okay. The beginning is 50, and the end is end. End is here. Everybody forgets that end does not point at 20. End is 1 past 20. Okay. So which elements are this going to sort? This range going to sort? We're giving it a pair of pointers, starting at 50, going to 20. And so you can see the first 2 here. Very good. The first 2 here were not sorted, but the second half of the array was sorted. How can I write this code to sort the first half? Like, let's say the first, should we round up, should we round down? Let's say the first 3. Give me code that would sort the first 3 elements of the vector. Should I do vector.end +3? Crash. Nope. Don't add things to the end. That's bad. And don't subtract things off the beginning. That's bad also. So how do we sort just the first 3 elements of the array? Vector.end -2. Vector.end -3. Vector.end sorts up to the 20. Vector.end minus 1 sorts up through the 40. Vector.end minus 2 sorts up to the 50. So do minus 2 here. And sure enough, the first 3 elements are sorted now. The last 2 are left alone. Okay. And this notion of a range is used all throughout the standard library. And if you're curious, like, well, what functions are there? That's a great question. Somebody asked me on Discord, well, what functions are there besides sort? Sort seems useful. What other things are there? In all caps, very good, Tipton. We don't want this to be a bland lecture, right? So, find, that seems useful. We could find things, like if you have a giant vector, find find the first instance of something, right? So if you've got like Hamlet and you want to search for the first instance of Ophelia, you can use find. Let's take a look at this one. So you can look at this stuff up here, and this probably looks like just symbols on the screen. After you get more experience, it'll mean a little bit more to you, but usually what you should do is just scroll down to the bottom here and just take a look at the example code. And it's got all sorts of different examples of how you can find things in a vector. And more than just a vector, actually, but how to find things in a vector. So if you got 1, 2, 3, 4, you can search for the number 3. And what it returns is actually a pointer to the first hit, or an iterator, to be specific, to the first hit. And if it's not found, it returns an iterator to end. Okay, so let's show you what that looks like. Find vector.begin, vector.end, searching for the number 40, and auto iterator. So if the iterator equals vector.end, this means not found. Otherwise, cout star it. So if 40 is in there, it's going to return a pointer to the element holding 40, and so it's going to print 40. Exciting. Found. Make it a little more exciting. And if 40 is not in there, then it will print out not found. Look, we found a 40. But if we're searching for the number 42 instead, not found. Useful. Yes? Do you guys concur? It's darn useful being able to find things. Like, that comes up, right? Helps a bit, right? Like, like you're doing wedding planning. Have I ever seen this? Like, you type in grandma's name. Maybe I entered grandma already. You want to search it, like, hey, we don't want duplicates, right? So, you conquer. It's faster too. Yeah, so find, super useful stuff. Maybe I should have left sort in there. It's just examples of things you can do. So just comment this out. So it's a vector. Which is a vector. What other things? There's random shuffle. This is kind of cool. Random shuffle the whole thing. Why not? Vector.begin, vector.end. Again, we're passing in a range. We're passing in the whole thing. We're basically saying sort the entire, shuffle the entire vector from the beginning to the end. Okay? Anyone want to guess what random shuffle does? Let's print it out and find out. Sure seems like it's shuffling to me. Gets you a 0 sugar Dr. Pepper. That's good. 0 sugar is good. You don't want to be corrupting your body with all that sugar. All right. Yeah, so random shuffle, that's kind of neat. I have a whole rant that I go on most years on people implementing their own shuffle algorithms, which seem to universally be badly written. I don't have time today, but ask me sometime about my experiences as a beta tester for Magic the Gathering Online, and when I found bad shuffling in Magic the Gathering Online. I could have used it to make millions, I say, but instead I reported the bug and they fixed it. So, Magic the Gathering Online is still garbage. I mean, it may very well be garbage. The user interface has a lot to be desired, but at least they shuffle things correctly now, as far as I can tell. I haven't played in a while. Okay, so this website here, CPP Reference, is your friend. Okay, so CPP Reference is the best reference material for C++. It looks like, I don't know, it's very text heavy. It's not very graphically appealing, but I actually really like it. And Bedencourt will go off on how great CPP Reference is. It's hands down the best reference for C++. It starts off over here with, this is all like the CSI 40 stuff over here. What we're going to be talking about today, though, is like the stuff over here, right? And so algorithms. Well, what kind of algorithms are there? How about sort? That seems cool. And for each, for everything in a thing, search, find, transform, generate. That's useful. So generate could be used to like generate, like what if you want to make a vector filled with random data? Very common thing, by the way, for two reasons. Testing, like a lot of times you want to test your code, and when you test your code, a lot of times you just type in zeros for everything, you know, because like you don't want to fill this giant image with just like you don't want to type it, right? And so a lot of times your algorithms will break if you just fill it with random noise. And so it's actually really important to have test cases that will just load your arrays with just completely random garbage data and see if your thing explodes. I actually worked for the electrical engineering department at UC San Diego, and their code would explode under various circumstances just because they hadn't tested it thoroughly. So being able to just fill an array with random data very quickly and then throw it through your algorithm and see if like it segfaults or something, very useful. It's also really useful if you're doing like numerical simulation stuff. So you can like start with like if you're simulating like a body of water, you can start with like all the particles and sort of like random velocities and things like that. So because if you simulate like water and everything's at complete rest, that's basically like absolute zero, right? Like nothing's moving. So it's ice. You know what I mean? And so usually like for simulation and numerical like approximations and things like that, a lot of times you'll start off with like random values. And then as the simulation runs, like it sort of like evens itself out and stuff like that. So an actual user walks into the bar, asks to use the bathroom, and the bar goes up in flames. Yeah. So let's talk about generate. So if I were to make a new vector, let's make a vector of doubles named vector2, and it's of size 1. It's too many. Let's make 10 so it fits on the screen. Generate, super useful thing. Generate from vector2.begin, vector2.end, and what you pass for the third parameter is randouble, is a function. Does this function randouble exist? What do you guys think? No, I haven't made it yet, right? So last time we talked about like forward declarations and things like that, like header files. Remember, header files are full of forward declarations, so we just know something exists. I'm just going to do it in the same file here so you guys get a little bit of experience with it. So random double is going to be a function that returns a random double. All right, cool. Rand double, like that. And I don't know, we'll just return rand. I don't know. I don't know what I want anymore. modulus that divided by 100 as a double. So this is going to give us a number from 0 to 99 divided by 100 double will give us a 0 to 1 almost. It's not quite 1. Do that. So this will give us a number from 0 to 1. And so this is actually quite common when you ask for a random float or random double. It's quite common to just be given a number from 0 to 1 by default. Very easy. So we are going to flood this array, or vector. We got 10 values in there. They're all 0 filled by default. With this, we're going to fill it with 10 random numbers from 0 to 1. You guys with me? You guys cool with that? It's very simple. It's one line of code. One line of code. This looks like 2. It's one line of code. Where you just say, boom, fill it with random data. Cool. And if you don't like having to make your own function like that, next time we're going to talk about lambdas, and lambdas will actually allow you to do this whole thing on one line of code. One line of cool code. Okay. So that's going to look like this. I'm printing vec, not vector2. Let's try that again. And there we go. So we got numbers from 0 to 1 filling this array. And it looks like there is no randomness because I took out the srand. There we go. Oh, we got an actual 0 there. Look at that. And an actual 1. Cool. What are the odds of that, huh? 1 out of 100. 101. Okay. Hashtag include random. Nah. It's included by default. I have the linker set up to include link in and include things kind of by default. This might not work on another system. Okay, so now you might be wondering, like, wait, what's going on up here? We have here const auto. Const auto. You can do that. You can do that. And the answer is no. You used to not be able to do that. This is actually C++ 17, I think, was when they added this functionality. But this code here is going to work with any kind of vector. In fact, it'll actually work with not just vectors, but any of these standard library container classes. Linked lists, which you don't know yet, hash tables, which maybe you know if you had me for CSI 40, maps, unordered maps, things like that. This print function will actually print any data structure of any type. Vector events, vector doubles, anything. Okay, kind of cool. Hash map. So how does this thing work? This thing that, what do we call this? What do we call this again? What is the name of this kind of for loop? You guys remember what the name of this kind of for loop is? It is a range-based for loop, or a ranged for, or range-based for loop, however you want to put it. Range-based for, arranged for. I've heard it called different things, but now you know what a range is, right? Home on the range. A range is a pair of iterators. So what's actually happening here is it actually will rewrite this thing here. This colon here, it's something called syntactic sugar, where it looks like something, but it actually replaces it with other code. And the code that it's actually going to replace it with is a second version of a for loop. This is option 1 for printing out a vector. Option 2 is the iterator-based for loop. And this thing here is actually converted by the compiler into option 2, which I'm about to show you. For iterator equals begin, as long as the iterator is not equal to vector.n, iterator plus. Technically, I don't need the curly boys, whatever. See out the value pointed to by the iterator. Option 1 and option 2 are not just equivalent, it actually rewrites option 1 as option 2. Actually, it probably rewrites it like this, which is equivalent. There's actually a global function called begin, and it does the same thing as vector.begin. It's literally just two different ways of getting the beginning of the vector. Okay. How do we make our own iterators to make range-based for loops for custom classes? You write a begin function on it, and you return a pointer to the first element in your linked list or whatever. If you're doing a vector class, your begin returns a pointer to the beginning of the array, and your end returns one past the end of the array, and that's it. Then this will work. It's pretty easy. We'll probably get to it on Monday. So, any questions about this? Let's maybe look at a picture and see if we can run through the logic here. So here's the code. On a scale of 1 to 10, how much do you understand this code here? Option 2. It's actually exactly the same code as option 1, but I didn't make it const on it. Const. Yeah, maybe it can't be const. Whatever. Close enough. It has to be constant begin, I guess, and then constant end. And then we can get a constant pointer out of it. I don't know. Whatever. Doesn't matter. We're not changing anything anyway. You make it sound easy? No. There's a lot of stuff going on here. But what it's doing is this. For every element in the vector, print it out. But there's like a star. And remember, people are scared by pointers. So, scary. Scary code. But conceptually, what it's doing is this. But do you understand what's happening here? Sell it. This is a fairly common for loop. Like if you go to CPP reference, you will see probably algorithm library. I don't know. Let's see if I can find something copy or something. Yeah. No. Basically, yeah. First is not equal to last plus first. Yeah. Basically the same loop. So this code you'll see everywhere. You'll see this code everywhere. And I lost connection. Anyway, the only advantage this has over this is that, like, let's say you wanted to only print out like half the vector or something like that. Then you could stop early. You have a little bit more control over the for loop. I did get booted from the server, yes. In the late, great Age of Empires 2 lobby macro once said, "Don't point that thing at me." To which I say, 11. Okay. So, iterators, C++. Only 90 kids would get that joke. I'm kidding. People still play Age of Empires 2. And deservedly, it's the best RTS ever made. Okay. Let's see if we can get a picture of these things here before I get disconnected. Sure. Why not? Okay. I don't want to save it. No, I don't want to save it. Just show me the image. Okay. Okay. So let's say this is... okay, fine. I will save it. Okay. So we've got our source code right here. And here we've got a picture of our vector. And so let's just fill our vector with like random numbers, 2.3, 3.5, 6.7, negative 2.1, negative 0.1, 1,000, -6. Okay. In a for loop, the first thing that happens is this. So this is going to create an iterator. An iterator is a pointer is an iterator. They're different, but they're the same. They're really conceptually the same thing. An iterator behaves just like a pointer. And so we're creating a pointer called it, right? And the iterator is pointing at the first element in the array. So we then check to see, is the iterator pointing at end? End, of course, is pointing here, right? In the special sentinel zone. You're never supposed to print this, by the way. It just tells us when we've hit the end, okay? So is the iterator it pointing at the end currently? Yes or no? Let me know. No. So we do the for loop. We print out the value pointed to by it. So what value is pointed to by it? 2.3. Very good. And then the last part of the for loop runs, the iterator plus plus. Iterator plus plus means the iterator now points at the next element in the vector. And we go and check again. Is the iterator now pointing at the end? What do you guys think? Nope. So what value do we print? How does it know when to stop? We're getting there. It's going to print out 3.5. Okay. We then iterator plus plus, and we print out 6.7. Then we print out -2.1. Then we print out -0.01. And iterator just keeps going on and on and on. Oh, shoot. Wrong it. Sorry. My bad. And then it prints out 1,000. And then it prints out -6. And then here, we just printed out -6. We say iterator plus plus. So it now runs off the edge of the array, and the iterator is now pointing here. So is it true that iterator is not equal? Is it true that iterator is not equal to the end of the vector anymore? We all float down here, exactly. Except these are doubles, so. It's a vector of doubles. Rude. No, it was a great joke, float. Yeah, sorry, Alessandra, I don't know where that came from. I guess if you just say it enough times, like a scary clown appears. So, it is not equal. It is true. Let's see. I forgot which way I asked it. Anyhow, iterator is pointing at end now. And so this becomes false, and it ends the for loop. So it will have printed out each of these elements one at a time, and then when the iterator points at end, this part here becomes false, and it quits the for loop. And what's, you're kidding? Okay, good. Yeah, these things just, I don't know, they just come out of nowhere. So let's go back on the server, restart session, and then main.cc, recover, save and quit, delete. Shoot, I got a process still running. So let me show you guys how to handle this, by the way. You've got a process still running, and you're pretty sure you're not connected to that process anymore. You can kill it. So type kill, and that process, boom. And then now I can delete that swap file. Okay, so I'm going to recover and save it out and delete the swap file. I'm good to go. Here. All right, so now what's interesting is that this will literally turn into this. It literally just replaces the range trace for loop with this. But this might actually explain like some of the weirder error messages that I've seen, right? So like, what if I tried doing this? What if I said for every integer x in the number 5, cout x? Does this work? Think about what it turns into. Will this code compile? What do you think? I haven't hit escape yet, so it's not running commander of completion on it. Is there a vector.begin or a vector.end on 5? Yeah. No. There's not. And students have asked me, like, what does this error message mean? No viable begin function available. And you might, like, if you hadn't had this lecture today, you might be like, what do you mean the begin function? Begin. What do you mean a begin function? You know, what are you talking about? Well, now you know, right? Do you guys know? Do you guys know why it's trying to find a begin function on the number 5 and failing? Yeah, 5 has no, there is no dot begin. There is, like, begin, the global function doesn't take an integer. Yeah, it's trying, it literally writes this code here, and it's as if it had written, like, begin, 5, and it's like, there is no begin, no. What? And so that error message, like when you understand kind of what's happening with ranges in the standard library, like compiler error messages start making more sense. If you did actually want to do this, this works. You don't get it now? So the range-based for loop, whenever you do this range-based for loop, it's saying, starting at the beginning of the data structure here, going to the end, print out all of the elements. 5 is not a data structure. The number 5 is not a data structure. It does not have a dot begin. It does not have a dot end. If I made this a float or a double, it still doesn't work. Begin and end are only defined on, like, vectors and arrays and maps, hash maps, and things like that. They're not defined. Like, there is no beginning of the number 5. Like that, there's no, like, it doesn't make any sense. So how do you fix it? You can do this. And so you can actually make a list just like this. In Python, it would be called a list, at least. And C++ will very happily convert each of these things into an integer and print out 5, 6, 7, 8. 5, 6, 7, 8, like that. So you can make a on-the-fly data structure if you want. This is something called an initializer list in C++. And then you can iterate over that. So initializer lists have dot begin and dot end defined on them. What about, and I'll leave that in there for you guys to admire. What about arrays? So if I have an integer array of size figured out that has 5, 2, 3, 1, 4 in it, can I do, like, auto it equals array dot begin? Is there a dot begin member function on a array? Is it a class? Like, only classes can have dot functions on them, right? So you would think, like, okay, well, you must not be able to use a range-based for loop with an array, right? Makes sense, stands to reason. However, there is actually an overload for it, like this. Pointers are arrays and arrays are pointers. So what value is this going to print out? So when do you use a range-based for loop? You use it when you want to do something, when you want to perform an operation on an entire data structure. Like this one here, prints out the entire data structure. If you use the iterator-based one, you can do things like, say, print out the first half, the middle third, the last half, things like that. It gives you more control. And then, of course, there's still, like, the regular for loop, right? So something like this, for I equals 0, I is less than vec.size, I plus plus, cout vector dot at I. That way works too. And this also gives you control over which parts of the thing you're iterating over. Like, you just print out every, every even element or something if you wanted. Sarah, does that make sense to you? All three of these things right now are doing the same thing. Okay. So range-based for loop is less typing. It is more compact than these other routes, you see. It's a lot less typing. It's also safer. Okay. With the range-based for loop, I can never go out of bounds, right? If I had this guy here, there's a chance that I could have like a out of bounds, right? Here, I could, accidentally go out of bounds, right? So if I were trying to run that, we got a bunch of zeros. Didn't go out of bounds far enough, I guess. Let's kick it up a notch. And we segfault. Okay, you cannot segfault with a range-based for loop. It is safe. There is no way of going off the left, off the right. You just always work over the entire vector. So it is my default go-to way of looping over a vector if I want to do something over the whole thing. If I want to print the whole vector, range-based for loop. If I want to increase all the values of the vector by 1, range-based for loop. Okay. Safe is good. Safe and fast to write. It is safe and fast to write. Now, coming back down here, what value is this going to print? We're creating an iterator. It's not an iterator now. It's actually a pointer. Pointers are iterators and iterators are pointers, although they're not. They pretend to be. We have a pointer at the beginning of the array, and we dereference it and print its value. What value is this going to print? What value is this going to print? We have a pointer to the beginning of the array, and we're going to dereference it and print it. Mm-hmm. 5 it is. Okay. What if we just did this? What is this going to print? The whole thing? What is an array? The entire array? What is an array? An array is a pointer and a pointer is an array. So there is literally no difference between what I had before and what I have now. An array is just a pointer to the beginning of that chunk of memory. It does not know where the end of that chunk of memory is. You can figure it out, but this code is literally the same as this code. Literally the same. The beginning of an array is literally the array. And so what value is this going to print to the screen? How do you print the whole thing? Well, I have a print function. That's convenient, right? Won't work with this, though. Because when you pass a pointer, when you pass an array to a function like this, it turns into a pointer. So it has the beginning, but it doesn't have the end. So, I don't know. It's found in a second. So what if I printed out array plus 1? What value is this going to print? I'm going to make a pointer to the array, and then move the pointer 1 to the right, and then dereference that pointer. What value is that going to print? 2? Okay. What about plus 5? What value is that going to print? 4? Five array is pointing at 5. If we go 1 to the right, we're pointing at 2. 2 to the right, 3 to the right, 4 to the right. 5 to the right is here. Like quite literally off the edge of the array. It goes to the X box, exactly. So what would we call this? This pointer here, this iterator. Which iterator is this? If we're dealing with ranges, right? If we're dealing with ranges, what did we just have a pointer to here? End. Yeah, and in fact, I could have just done end, and that's the same thing. So what's interesting is that we can actually use a range-based for loop with an array as long as we don't pass it to a function. It's really stupid and garbage, and that's why we use vectors, but we can do it. So we could actually say this to answer your question, Sarah. So for every integer in the array, cout that integer. But if we tried calling print on the array, it won't work because, well, actually, it did work. Suspicious. Oh, interesting. Because it's auto. Oh, that's so cool. That worked. Okay. Anyway. Normally, when you write these functions, it won't work because it does pointer decay. That was actually quite clever on C++'s part. We'll just pretend that didn't happen. So this works though, because array begin points at you, array end, or begin array points at 5, end array points at the Xbox. So this range-based for loop here works. Isn't that cool? Yeah, you could use span and things like that for a kind of a view on something. Isn't that cool? You can print out the whole thing because begin and end are defined on it. Guys with me? Why didn't I call the function? C++ is being too clever for my pedagogical needs. But we'll just say it's because it doesn't have a dot size on it. How about that? We can't call it. But it's actually passing in a normally when you, okay, so normally when you do this with an array, you do this. And when you pass an array to a function, it decays into a pointer. And pointers only are the beginning of the array, not the end. And so it doesn't know where the end is and the thing doesn't compile. But this thing is actually being very clever and actually passing it in such a way that the beginning and ending are actually defined on it. And so so the only thing that's failing is the dot size version of it, which will not work. So how does it know? It's auto. It's magic. It's avoiding pointer decay. And I'm trying to teach you guys pointer decay right now, so we're just going to pretend this didn't happen. Usually when you have an array like this, these things just immediately turn into like a pointer. Not an array, just a pointer to the beginning. The second you breathe on it. But it's being very clever with the auto thing here. So, okay. So, accumulate's pretty useful. Keep you around, I guess. Okay, so accumulate. Anyone know what accumulate does? It adds up everything in the vector. Okay, technically anything in the range, because remember, ranges work with any of the container classes, linked lists and hash maps and everything, right? But I'm just using vector right now because that's kind of the only data structure you know. So I could cout accumulate from the beginning of the array, or I could just pass an array to the end of the array, or I could just pass an array plus 5. with a subtotal of 0. And accumulate is in... Okay, so we're going to add up all of the elements of R. Anyone want to guess what is going to be printed out here? $14? No, I don't think so. It's going to add all the numbers up. Yeah, 15 is correct. Very good, sir. So, unless I've done my math wrong. No, 15. Okay. So, there is one sharp edge. There is warning. The 0 passed in is the starting number, or subtotal. It's like if you were to start with like 100, what number do you think is going to be printed out here? Why did I write +5? Oh, I could have written the end of the array if you wanted. Remember, +0, +1, +2, +3, +4, +5. So that's the end of the array. It's array +5. 2 + 2 is 4. -1, that's 3. Okay. If we start with 100 as our subtotal and we add everything to 100, what number are we going to get? We almost never do this. Like, it's kind of a stupid design. But what number gets totaled up at the end? 115. Yeah, you're correct. Thank you for participating. Everybody else is too scared to put their egos on the line for that. Yeah, 115. Good. Now, there's a kicker here. And the kicker is everybody always just puts a 0 there. Because why would you? We just want to add up all the things in the vector, right? The kicker is the return type from this function. The return type is based on the type of that 0. Okay, what does that mean? So let's say we got a vector of doubles here that is equal to 1.1, 2.2, 3.3, 4.4, and 5.5. Eleven, 16.5, right? If I'm doing the math right. What do you guys think? 16.5, 16 and a half? Are you guys doing the math or just 16 and a half? All right, cool. So let's see if tipped in is correct. 16 and a half coming up. Nope, 15. The reason for that is because we put an integer here. If you put an integer there, it does integer addition. So all of these nice little 1.1s and 2.2s turn into 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 summed together is 15. That is a hell of a sharp edge. Everybody forgets about it. If you want to do double arithmetic, you have to put a period there. And now we are doing floating point arithmetic in this thing. Everyone forgets it. We're going to get 16 and a... Oh, shoot. Sorry, wrong array. Vector.begin, vector.end. Let's go back. That's hilarious. They both added up to 15, though. That is actually quite funny. So, going back to that, we're adding up the doubles now. 150. Wait, what? Wrong vector. Third time's the charm. Let's do this. Let's go. All right. Vector 2, adding it all together, should be 15. There we go. And if we make it a floating point, then we will get 16 and a half. Ba-bam. Like that. Okay. That's actually quite funny that was 15 as well. So, all right. So that, though, is a sharp edge. That number there actually governs the return type that is added up. And to me, like, I got issues with that. Like, for one thing, like, I think that, like, why is that necessary? It won't compile unless you have the subtotal there. Just give me a subtotal of 0, dude. Like that's all I ever want to use it for, is just a subtotal of 0. Well, how do I know what type to return? The type of the vector. Just figure it out. I don't know. You know? And so it not only is a sharp edge, it is a required sharp edge. They hand you a knife with no handle on it. You just have to grab the sharp handle with no hilt. So, yeah, a lot of students will like get buggy results from accumulate, and that's why. If you're accumulating across doubles, you probably just have a 0 there, and it is killing your decimals with prejudice. Okay. What if you want to reverse the vector? Anyone want to guess what the function to reverse a vector is? Pretty metal. Thank you. Reverse, yeah. Okay, so reverse comes up a lot actually in stuff. Job interview questions. A very common job interview question is like reverse a linked list. And if they gave that to me, maybe I should print it. If they gave me that assignment, I would just call reverse on it, man. I'd just be like, here you go. Because that's how I would do it. Like if you ask, like if in my job I needed to reverse something, I would call reverse. I don't want to write it. I'll just call it. You know, I can write it. I have written it. Do I want to? No. Why would I write it? It exists already, you know? And so you can see the numbers went from 1 to 5. Now they go from 5 to 1. Okay. And we can comment out this version as well so we don't get a double print every time. And so oftentimes what you do is you're like, I would call it reverse. And then they're like, all right, that's cool. But now we got you, but like we want you to actually write it on the job interview question. Because they want to see if you can write it. In fact, most job interview questions you're going to get for Facebook and Apple and things like that are taken from this class, CSITE 41, and from the next class, CSITE 26. Those are your two big classes that you need to pay attention to a lot for job interview questions. They come up all the time. So yeah, reverses things. We went over generate. Bencourt, you have any popular standard library functions? Basically, the goal here is like if you know what's out there already for like searching and sorting, like you just don't have to write it yourself. You just use what's written, and then you can move on to the fun stuff, right? Like and even at Facebook, like they wouldn't, like even though they hire you based on your ability to write a reverse, when you actually work there, they don't want to pay you money to write reverse. They want to pay you money to steal people's personal information. Like that's what they're hiring you for, not to like waste time reinventing the wheel, right? And so there's this kind of disconnect between like the job interview process and what you actually do. Like they'll make you write reverse, and then after they hire you, be like, no, we don't want you to write reverse. We want you to use the standard library function. So random for Perlin noise. Let's see what else we got in here. Move copies from one to another. Reverse copy. Oh yeah, let's do a reverse sort. So let's do a sort. And so if we sort these numbers, they should already be sorted, right? 1, 1, 2, 2, 3, 3, 4. What if we want to do a reverse sort? Well, there's actually a really easy way of doing it. There are these things called reverse iterators. Oops. No. Okay. And so there is the reverse begin iterator, which points to u, the last element. So a lot of people ask, how do I point to the last element? Reverse begin. There you go. And then the reverse end element is one before the beginning of the array, is the reverse end element. And when you go to the next, it travels backwards through the vector. So the upshot of this, it seems kind of weird, right? The upshot of this is that it sorts the vector backwards. So it's a very simple way to just sort greatest to smallest. You just use reverse iterators instead of forward iterators. You use the backwards ones. Everything comes out backwards. There you go. One letter different, greatest to smallest. There's other ways you can do it. You can pass in like the greater double function, I think. I'm doing that right. And then it reverses the other way around. So I've double reversed it, so it's back to the original now. Can't you say starting from the end? Nope, you can't. Because the way that the range works is that it goes plus, 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 plus. There's nothing plus, plus, past, end. You are off into La La Land. If you use the reverse iterators, plus, plus actually moves them backwards through the vector. And that's why the reverse iterators exist. So you can plus, plus backwards through a list or a vector, something like that. Yeah, you can't ever print the end or use the end in any meaningful sense. It's just the finish line. And rend, which is a pretty cool name, like you're going to rend somebody with your claws. You know. You can't print that value either. It's a finishing line. Can I point it at 5? Yes. So if I see out vector2 dot reverse end -1, this is a iterator pointing at 1.1. Actually, you wanted this 5. Then we're using rend array -1 star. There, 5. So if you point at the reverse end -1, it comes back into bounds. So the reverse end is here before it, so -1 is 5. Too many double negatives, but it's easier to just use begin. So this is definitely job security code right here. When you could just say that. Because the array is pointing at 5 already. You reference it, get 5. But, you know, if you don't like people understanding your code, then definitely reverse end array -1 dereference. There you go. Nobody's going to be able to fire you because they won't be able to fix it if it's buggy. Okay, so that is our standard library lesson. Highly useful. You're going to be using these functions for the rest of your life, hopefully. Lambdas, ternary. We'll be talking about lambdas on Monday. Okay, so keep working on imaginary homework and try and get as much done over the weekend as possible. I didn't get many questions, so hopefully that was a good sign and not you guys just had Taco Bell or something. Combining both to create dark patterns. Yeah, we're going to double it. Yeah, like we're reverse sorting it and then reverse sorting it a second time, right? To just do a regular sort. This is genius here. It's just a regular sort. Double negative. Okay. All right. Well, I hope you guys had fun today. No comments. No. Yeah. Every variable has to be named X or X2 or X3 or X4. Yeah. All right. So work hard over the weekend. Any questions? I'm always available. We got ballroom dance in 20 minutes. So I got to get to that. All right. See you guys. Bye.